I am working in the Department of Electrical Engineering and Computer Science. I was hired in that department originally, but then later on I was also joining the new department of MIT, which was Department of Biological Engineering. So now I'm belonging to department. So my original background is in physics. I did my undergraduate studies in physics. So whenever I look at the problem, I look at the fundamental principles, fundamental phenomena, and the physics principles that governs that phenomena. And then being in the engineering school, engineering department, I always think about what kind of application you can draw upon this fundamental physics phenomena. And so that is sort of the modus operandi of my research so far. So we always begin with some mundane, obscure physics phenomena that probably not many people know about, such as ion concentration polarization. But then later on, you tend to identify, you start with some scientific studies on them, you try to characterize them, you try to understand the physics behind it, and then you realize that, well, there are some things you can do with this phenomena. So maybe you can make this device, or maybe you can make another system to, capitalize on this unique phenomena. So that has been my research method. So more recently, I have been publishing papers in two completely new areas that I have never been trained on. So one is the area of water purification and desalination, and the other area is neurotechnology and prosthetics. But then in those two areas, the basics all came from the one phenomena that I have been studying on for about 7-8 years now, which is ion concentration polarization. I think my background in physics helped me a lot in terms of forcing me to think about the fundamental level. When I see neuroprosthetics, I don't think about the prosthetics. I think about what actually happens between the electrode and the cell. And so that's what I got from my physics education. But then I think the way that I structure my research at MIT has to come from the environment of MIT itself, because this place just has so much emphasis on the practical use of the knowledges. And whenever I see other faculty member or other student present their work, every single one of them start with their talk or presentation by talking about what these things might be used for. Okay? And that's just the culture of this place, and just the practically minded scientist. So a lot of it actually, I have to admit that, came from the MIT where I actually work. And it's just the culture of this place is so focused around the practicality of the science and engineering. Other than that, I have to admit I am a bit of a daydreamer. I actually like to think about some weird things, and it's a very clear contrast between myself and my wife. My wife is a bit of a, in a way, very detail-oriented person. But then I'm always daydreaming. So I always think about the way that I can do the same thing, but in a different manner. And I think some of it is actually from my character, because whenever we try to find some place to go, my wife starts thinking about what is the easiest way to find that place. You go straight this way and make a one turn, and then you get there. Now, I'm always thinking about, is there any shortcuts, or is there any, easier way, or is there any way that I can avoid the traffic stop? So that's just my character, some of it. So.